Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the volume and surface area of prisms. So firstly, you need to be able to identify a prism. You probably know a prism is a 3D shape and that this here is a prism. So what makes a shape a prism? It has what we call a consistent cross-section. So in this shape here, this is the cross-section, this triangle. Now note, despite my terrible drawing, that the shape at the back is congruent. It's exactly the same shape, same size as the front. So we have a shape repeated at the front and the back, or the top and the bottom. That's what I mean by consistent cross-section. So a prism is just a shape repeated at the front or back or top and bottom with a whole heap of rectangles around it. So this here is a triangular prism because its cross-section is a triangle. So for any prism or cylinder, you can use these formula. For volume, it's just area of that cross-section times perpendicular height. For the surface area of any prism, it's twice the area of the cross-section plus the perimeter of the cross-section times the perpendicular height. Now note, when you are finding the surface area, you need to be clear as to whether the shape is closed or open. So by closed, we mean that the shape has all of its surfaces. So if the shape were open, if one of these surfaces were missing, you would have to adjust your calculation of the surface area accordingly, but it doesn't affect the calculation of the volume. So I'm going to calculate the volume and surface area of this shape here, assuming it is closed. It has all of its surfaces. So let's start with the volume. So firstly, we need to find the area of the cross-section, the area of this triangle here. Well, that's actually not that easy because the area of a triangle is base times perpendicular height divided by 2. So we're going to need to use Pythagoras. So if this here is h, this side here will be 5, and this side here is 13. So Pythagoras tells us that h, because it's the shorter side we subtract, it's the square root of 13 squared minus 5 squared. H must be 12 meters in length. So note that you can perform this trick dividing the triangle in half exactly, as long as the triangle is isosceles or equilateral. So the area of the cross-section, the area of the triangle, is base times perpendicular height divided by 2. So that's the area of the triangle. Now we need to times by the perpendicular height of the prism. Now sometimes people get a bit confused when I call it the perpendicular height. We don't mean the height of the prism standing up necessarily. When I say the height of the prism, when I'm talking about this h here, we're talking about the dimension that is perpendicular to the cross-section. So this 25 is perpendicular to the cross-section, so I'm going to substitute here h for 25. So the area here is just 60 times 25. It's 1,500 meters cubed. Now, just so you know, 1 meter cubed is 1,000 liters, so that means this would actually hold this many liters. A meter cubed is actually really big, holds 1,000 liters. So this shape here would hold 1,500,000 liters. All right, let's calculate now its surface area. So we've already done some hard work. We've already found A, the area of the cross-section. That was this here, 10 times 12 over 2, which is 60. So the total surface area is 2 times 60 plus the perimeter of the cross-section times perpendicular height. Well, the perimeter of the cross-section is 13 plus 13, 26, plus 10 is 36. And as we said before, h, the perpendicular height of the prism, is 25. So just putting that on our calculator, we get 1,020. This is in square units, so it'll be meters squared. All right, let's now look at a composite prism. So this here is a composite prism because it's basically two joined into one. What we have here is a half cylinder on top, this one here, and then we have a rectangular prism down below. This is still a prism because it has a consistent cross-section. This bread-shaped thing, loaf of bread-shaped thing here, is repeated at the front and the back. so it is a prism. That means we can use the formula from the previous slide. So let's first find the volume. To do that, I need to find the area of the cross section and times by the height of the prism. So the area of the cross section, well, we have here a rectangle that's 15 by 10, but we need to add this semicircular part here. So the area of a circle is pi times radius squared. So the diameter is 10, the radius is half that, which is 5. So the area of the circle is pi times 5 squared, but we need to divide it by 2 because it's only half a circle. This here is the area of the cross section. So to find the volume, we simply multiply that by the height of the prism. So note again, I didn't find the area of the circle here and round it. I used the exact value because I'm going to then do something to it, in this case times by 20, and I don't want to introduce errors. I put it on my calculator exactly like that, and we get about 3785.4, and it will be centimeters cubed. So just so you know, this will be about 3,785.4 milliliters, because a centimeter cubed and a milliliter are literally the same thing. And then you just divide by 1,000 if you want it in liters. So it'll hold about 3.7854 liters. All right, let's now calculate the total surface area. So it's 2 times A. Well, A is what we just figured out here, so it's 2 times that. And then we add the perimeter of the cross section times the height. So what would be the perimeter of the cross section here? Well, if you go around, you've got 15 plus 10 plus 15 gives us 40. But then we have to find this length here. So the circumference of a circle is 2 pi r, but because we have half a circle, we need to divide it by 2. So it'll be 2 times 5 times pi, because 5 is the radius, divide by 2. That is the perimeter here of that base, of that cross section. And now we just multiply that by the height of the prism. So if we put all of this on our calculator at once to avoid introducing any errors, 2 times this plus this, we should get about 1492.7. Now area is always in square units, so it'll be centimeters squared. All right, let's now look at an example where we're finding an unknown length. So in this question, I've asked us to calculate the volume of a closed rectangular prism if its surface area is 954 centimeters squared, length is 12, and width is 11. So in order to find the volume of this prism, we are going to need to find what h is. What is the height of the prism? And to do that means we are finding an unknown side length from a measurement, in this case the surface area. So whenever you're finding an unknown side length, a dimension like radius, length, width, whatever, from area, volume, whatever, follow these steps. Write the formula, substitute what you know, and then solve. So for the surface area of a rectangular prism, because it is a prism, we know that we can use the formula total surface area equals 2a plus pH. Okay, let's go ahead and use that to find out what h is. So what would A be? Well, the area of the base will just be a rectangle that's 12 by 11. So the area of the base will be 2 times 11 times 12, which is 132. So the perimeter of the base is 12 plus 11 plus 12 plus 11. It's actually 46. So we get 2 times 132 plus 46h. Now we're going to substitute total surface area for 954 because that's what the question told us. So we get 690 when we subtract 264 from both sides equals 46h. Dividing each side by 46 gives us 15. H is equal to 15. That is the perpendicular height of the prism. So the volume is just going to be the area of the base, which we figured out was 12 times 11, 132. That's A, and now we're going to times by H, now that we know it. So you can put that straight in your calculator, get 1980, because its volume is cubic units and everything was in centimeters. It will be 1,980 centimeters cubed, which is 1.98 liters. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.